So today we're going to start chapter 11. Chapter 11 is what's going to be on your final exam, which is really just your final test. Yes?
Is also the 9184 going to be in the test?
Okay, so today we're going to talk about sequences and series. So first, let's go through some definitions. So a sequence is a function that computes an ordered list. The function values a sub 1, a sub 2, 3, 4, a sub n are just going to be the terms of the sequence. Then an infinite sequence is a function whose domain is the set of positive integers. So for example, an infinite sequence could be written like this. They would have set brackets around it. And then it could be like 2, 4, 6, 8. And then you would see dot, 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 which is like an ellipsis. That tells you that it keeps on going forever. A finite sequence is if the domain of the function consists of the first n positive integers only, then the sequence is finite. So let's say I said list the first 5 integers. A finite sequence would be like 1, 2, 3, 4, 5. So if it said list the first 5 positive integers, notice there's no dot, dot, dot. This would be a finite sequence where it ends. Infinite, it keeps on going. So I could keep going with that 1, 2, 4, 6, 8, 10, 12, 14, 16, and I could keep going, all the even numbers. Now, this little notation up here with these little subscripts, they're not exponents. All this little 1 that's on here is telling you like the position or the place in the sequence it is. So like a sub 1 means that it's the first number in your sequence or the first term. A sub 2, this just means that it's the second term. So the little subscript, this tells you the spot in your sequence. So it would be the second spot or the second term. So that's what these little subscripts here are describing. So let's go ahead and take a look of what your homework is going to look like tonight. So I'm going to be giving you a rule. So what's written right here is the rule. And they're going to tell you to list, and you're going to fill them in the boxes. Write the first 5 terms of the sequence. They're going to tell you to start with n equals 1. So what we're going to be doing is every place that I see an n, I'm going to first replace 1, then 2, then 3, then 4, then 5, because it wants me to list the first 5 terms. So I would do a sub 1, and every place that I see an n, I'm putting in a 1. I'm going to follow order of operations, and my first term of my sequence is 2/3. So a sub 1, or the first term of my sequence, is 2/3. Then to find the second term, and again, it's got the little subscript of a 2. 2 plus 1, 2 plus 2, 3 over 4. And this gives you the second term. Then we're going to keep repeating it till we get to the 5. So a sub 3. And whatever the rule is that they give you, you're just going to plug in 1, 2, 3, 4, and 5, and follow order of operations. So plus 1, and then 3 plus 2, 4 over 5. It's the third term. Fourth term, put in a 4 for the n. 5 over 6. And then lastly, the fifth term, 5 plus 1, 5 plus 2, 6 over 7, and that's the fifth term. Now, as soon as you start to see a pattern, technically you don't need to go through this. Once you plug it into the first one and then do the next one, and you can see how the numerator is 1 larger and the denominator is 1 larger each time, that's how you can complete your pattern. So this is what you're going to be doing in WebAssign tonight. The first maybe 7 questions or so, this is all you're doing, is first finding the first 5 terms. Now, towards the end, they're going to say, find the 50th term. And they're going to say where n equals 50. So all you do is take out the n, put in whatever term they're looking for, plug that into the rule, and then add it up. In the 50th term, would be 51 over 52. So that's all you need to do in order to do the homework tonight. Let's try the next one. Again, we're following order of operations. So again, I'm going to find the first 5 terms. So a sub 1, and that's going to be negative 1 to the first over 2 to the first, which gives me negative 1 over 2, and I could just pull the negative out front if you wish. Then I'm going to plug in a 2. Now, for this series, the negative and the positive are going to alternate. Because remember, whenever you raise an odd number to an even exponent, it becomes positive. So negative 1 times negative 1 is positive 1, and then 2 squared is 4. So notice the first term's negative, second term's positive, third term, I'm raising a negative number to an odd exponent, it's going to go back to being negative. So again, you're just plugging in 1, 2, 3, 4, and 5 in for n to get the pattern or the series, the sequence. All right, let's try 4. Negative 1 to the 4th, 2 to the 4th, becomes positive 1 over 16. And then lastly, the 5th term, plug in a 5, follow order of operations, negative 1 over 32. I can pull the negative sign out front, and there are my first 5 numbers. So this is all you're doing in the homework tonight, in addition to finding maybe a 25th term. You don't need to keep adding the pattern, you're just plugging in whatever n value they give you. Next, what we're going to do is learn how to find the sum of a sequence, which is called a series. So if I said to find the first 5 terms and then find the sum of that sequence, then you would have to have gone back and manually added negative half plus 1/4 plus negative 1/8 plus 1/16 plus negative 1 over 32. What I'm going to do is teach you some properties and some rules to make it simpler, where you don't have to take your time. List out the 5 terms. If it only asks you to find the sum, we're going to be able to use these properties and summation rules that I'm going to teach you. So let's first, though, talk about convergent and divergent. So when a sequence is convergent, what it means is it's getting closer and closer to some real number. So let's say our rule was 1 over n. And if I say find the first 4 terms, it would be 1 over 1, 1 over 2, 1 over 3, and 1 over 4. Notice how my numbers are getting smaller and smaller. So this would be a convergent sequence where my numbers are getting closer and closer. In this case, it looks like they're getting closer and closer to 0. A divergent sequence is a sequence that does not converge. It just keeps growing and growing and going towards infinity. A series is the sum of the sequence. And that's what all of these properties and rules are going to help us to find. They're going to help us to find what all of the numbers in our sequence will add up to be. And we're going to be introduced to a new notation. It's the Greek letter sigma. Looks like an E. So this symbol represents to sum up. It's called summation notation, or you might hear it called sigma notation. So this is the Greek letter sigma. Now the way that it'll be given to you is you're going to have your Greek letter here. You're going to have a variable down here set equal to 1. Generally, they're going to use the letter I, and then up at the top, they're going to have some number up here that is going to be our stopping point. So the I is called the index of summation, and it's the lower limit. So I equals 1, that's where we start. And the N up at the top, that's where we're going to stop. So it's the upper limit of the summation, yes.
So underneath the sigma is like I equals a number, and that's always the beginning, and on top is always the ending of the...
Correct. And in order to use any of the properties, that bottom number has to be a 1. Okay? If it's not equal to 1, then you have to do it by hand and plug it in, find all the numbers, and then go back and add them by hand. All right? So then what they would have here is like an a sub 1, or a sub I, sorry. And then what this really means is we're going to plug in all of these numbers until we get to the N. And that's where we would stop. So let's go ahead and see what this means. So let's look at some of the properties. So again, you should memorize these. And in your case, since you have open notes, have them written down. So the first one, the C in both of these represents a constant. So these are just a constant. It's just going to be a number. So again, to use any of these properties, down at the bottom, it always has to be set equal to 1. So if it's just a constant, all you're going to do is take the number that's at the top, that N value, and multiply it by the constant. So for example, let's say I have sigma notation here, and I have a 4 on top, and then I have a constant 5, and I equals 1. So to figure out what the sum of the first 4 numbers in this sequence are going to be, I take my N value, and I times it by the constant. So I'm going to do 4 times 5, and the sum of this sequence is going to be 20. What this is saying is, since there's no place to plug in any numbers, the numbers in my sequence are just 5 plus 5 plus 5 plus 5, and it gives you 20. Now, in tonight's WebAssign homework, you're going to get a question that's similar to this where it's just a constant. So, for example, if I give you in the WebAssign tonight, a sub n equals 2/5, and I ask you to find the first 5 terms, notice before when we did the examples, there was a place to plug in a sub 1, and we would plug in 1 and multiply it by whatever was there. There's no place to put in a 1, a 2, a 3, a 4, or 5. So my first term is 2/5. My second term is 2/5. My third term is 2/5. My fourth term is 2/5. So if it's just a constant, you're just rewriting the number that's there when you do the homework tonight. Now, if this were the question and it said summation notation, and this was a 2/5, and let's say this was n to the, or just put a 5 there, and I equals 1, notice there's no place to put it. So in order to find what this sum would have been, if I were to go back and add all these 2/5, shortcut way to do it, instead of doing 2/5 plus 2/5 plus 2/5 plus 2/5 plus 2/5, I could just take my n value, and I'm going to multiply it times the constant. And this sum is going to be 2. Because if you were to add these, 2 plus 2 plus 2 plus 2 plus 2, 2, 4, 6, 8, 10 over 5, and notice it gives you 2. So it's a fast way to add up all the terms of your sequence to get the series, to get the sum. And instead just take the n value, however many terms you're multiplying or adding or completing, and then multiply it by the constant. Everybody with me on that? Now in tonight's homework, you're not adding anything up. You're just finding the terms in the sequence, or if I said find the 50th term, in this particular problem, if I said find a sub 50, it's still 2/5 because there was no place to plug in the 50. Anybody with me on that? All right, let's try the next property.
Wait, real quick.
Yeah.
What do you mean by there's like you just said, there's no spot to plug in the 50? Like, is that because there's no n?
Correct. So like if this had an n here, then I would plug in, then I would have had to have plugged in 1, 2, 3. But if it's just an a sub n equals a number, just a constant, then all the numbers in the pattern are always going to be just that number.
Okay.
Does that make sense? All right. The next one. This one actually has a constant and then a variable to plug in. So what we would do is we're going to take the constant and we're going to put it in front of the summation notation. So for example, let's say I give you the sigma notation, and let's say I put a 3 here, and then a 5i, and I equals 1. So what I would do is I would pull the 5 to the front, I equals 1, and then put the I, and then what I would do is I need to take the constant that's out front, and then now I got to plug in 1, 2, and 3 for the I, add them, and the sum of that series would be 30. Now I'm going to show you a faster way with a summation rule where we don't actually have to put in 1, 2, 3. We're going to plug in the n value. The next property is when you have two things that are being added or subtracted, you're going to give them each their own little summation notation. So you just split it apart. Let's go ahead and look at the summation rules. The summation rules, when it's just an I, there's no exponent on it, is you're just going to take the n value, you're going to multiply that n value times n plus 1, and then divide it by 2. When it's an I squared, you're going to take n times n plus 1 times 2n plus 1 and divide it by 6. And then when it's an n cubed, it'll be n squared times n plus 1 squared, divide by 4. And we're going to see how to use these rules and properties, which is going to be tomorrow night's homework. Again, tonight's homework is basic. You're just plugging in 1, 2, 3, and 4, and 5 for n, and then listing the next 5 numbers in the sequence. So let's go ahead and try the examples. Actually, I'll show you one here of this one. Let's do summation notation. And let's put an I here. And my n value is 5, and I equals 1. So if I'm going to use this rule here, my n value is 5, and then I'm going to do 5 plus 1, divide by 2. 5 plus 1 is 6. If you want to simplify before you multiply, you can. And the answer here, the sum of that series would be 15. Let's make it bigger. Let's say the n value is 500. We obviously do not want to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to 500. So this is where we would use the rule. So again, I'm using this same rule because it's just an I. I would do 500 times 500 plus 1, divide by 2. I get 500 times 501, divide by 2. If you want to simplify before you multiply, you can. So I'm just multiplying 250 times 501, and I get 125,250. That would be the sum of that sequence. Let's try some examples. Pretty good? All right, so here's my first one. I'm going to use the property because it's a constant, the property I'm going to use is here's the sigma, and then I have n, I equals 1, and remember this was the constant, and remember we just take n times that constant. Actually, instead of a I, it's a c, because it's a constant. So n times c. So here, because 5, there's no variable here, all I have to do is n times c, which is going to be 40 times 5, and the sum of this series is 200. Because really what they had expected you to do was add 5 plus 5 plus 5 plus 5 all the way 40 times. You're adding a 5 and it gives you 200. So this is the faster way to do it when it's just a constant. The next one is a constant, and I'm going to use the summation rule for I. So this one I'm going to use the property. I'm going to be using the property of when it's the constant times I. So I'm using this rule, n I equals 1 CAI. And I break it apart. I pull the constant to the front, and then the AI there. So let's go ahead and pull it apart. And then I'm also going to use the summation notation rule for I, since I'm going to pull it apart. And that rule is n times n plus 1 divided by 2. So we're going to split this apart, put the constant out front, and then leave the I. So this was using the property, putting that in front, and now what I'm going to do is replace the I, and I'm going to put in the n times n plus 1 times 2. So I have my constant out front, and then I'm going to multiply it times 22 times 22 plus 1 divide by 2. And this gives me 2 times 22 times 23 divide by 2. If you want to simplify the 2's, and then you just have to multiply 22 times 23, and you get 506. So the sum, if you were to go back and add 2, and then you're plugging in a 1 each time, so 2 times 1 is 2, and then you'd plug in a 2, 4, 6. If you were to add these, once you get up to the 22nd term, it adds up to be 506. Number 5, we're going to split it apart. We're going to use this property where we give each one of the terms its own summation notation. So I'm going to do summation 14, 2i squared, I equals 1, minus summation 14, I equals 1, and then it's a 3. Remember, we can also take this 2 and put it in front. So now I'm going to go ahead and I'm using the rule, the summation notation rule for I squared. And remember, that's going to be n times n plus 1 times 2n plus 1 over 6. So for this one, I've got the 2 in the front, and then my n is 14. 14 plus 1, 2 times 14 plus 1 divided by 6. And then for this one, it's a constant. So here I'm just doing the n times c. So I'm going to be doing 14 times 3. So let me go ahead and do the math here. So the red becomes 2 times 14 times 15. This becomes 28 plus 1, so this becomes 29. And then 14 times 3 gives me 42. Now, if you want to simplify before you multiply, you can. You could just go straight across, multiply all this, and then divide by 6. It doesn't matter. If you weren't using a calculator, I could simplify this, make it a 3, and then simplify this again and make it a 5. So then I would get 14 times 5 times 29 gives me 2,030 minus the 42. And my final answer here for the sum of this series is going to be 1988. So if I were to take and plug in 1, 2, 3, 4, 5, 6, all the way up to 14 into this, get all of those terms and then add them up, this is my sum. So it's a lot faster to use the rules and the properties. Let's try the last one. I'm going to break it apart and give each one of the 3 terms its own summation notation. So I'm going to do summation notation with 6, and then I equals 1 for the I squared. Then I'm going to do it again for the middle term. Then I'm going to do it for the last term. Now, for the first one, I'm going to be using the I squared rule, which is n times n plus 1 times 2n plus 1 divided by 6. That's what I'm using for this one. Now, also on this one, remember we can take the 3 and put it in the front. So for here, what I'm going to be doing is the constant, which is the 3, and then the I rule, which is the n times n plus 1 divided by 2. And then for the last one, I'm using my constant rule, which is just n times c. So let's go ahead and fill them in. So my n on all of these is 6. So when I do the first one, I'm doing 6 times 6 plus 1, 2 times 6 plus 1, 6. So 6 times 7, this is 12 plus 1, so this is 13. Then the blue one, the constant is 3, and then 6 times 6 plus 1 over 2. So 3 times 6 times 7 divide by 2. And then the last one, my n is 6, my constant is 5. So that becomes a 30. Now again, if you want to simplify, the 6's will cancel. 7 times 13 is 91. Here, if you want to simplify, you could make that a 3. 9 times 7 is 63. Drop down the 30, add them, and the sum is 184. So that is it, using the rules and the properties to find the sum of a sequence, which is called a series. Now again, tonight you're just listing the first 5 terms, or maybe finding the 100th term or the 50th, whatever they tell you to find. And again, you just plug in the value of whatever term you're looking for, you plug that in for n. And then we'll get another homework assignment tomorrow. You guys are here for a long time again tomorrow, so you'll have the class period to work on that 11-1B. And we also still have time. We are here until 10:10, so we still have quite a bit of time.